Assalamu alaikum everyone. I hope that you all are fine. We have to continue with the same unit, basic statistics, and the same topic, frequency distribution. But before proceeding towards the further explanation of the topic, let's have a brief revision of what we learned in the previous lesson. Dear students, in the previous lesson, we learned about statistics. That statistics is the science of collecting, organizing, presenting, analyzing, and interpreting numerical data to assist in making more effective decisions. For instance, if we want to have the statistic of favorite fruit of the people of a particular region, so for that purpose, the first step will be the collection of data. Then the next step will be the organization and presentation of the data. As in this example, the data is presented with the help of pie chart for the sake of analysis. Then the next step will be interpreting numerical data, or in other words, we can say drawing conclusions about the data. As in this example, we can draw the conclusion that the favorite fruit of the people is apple. Then in the previous lesson, we learned about data. The data is a collection of facts such as numbers, words, measurement, observations, or just description of things. Then we learned about frequency distribution. Frequency distribution is basically the organization of data, where we classify the data into different groups in a table. In simple words, we can define frequency distribution, a table used in statistics, as a method of recording the data collected. Here we have an example of frequency distribution table. We are in a class of 31 students. We have to show that how many times they had played sports last month. So here we have the frequency. Frequency shows the number of occurrence of that data. Here we have the scores, means how many times they have played, and here we have the tally marks. This tally marks is used for listing down the observation, for telling the number of observation, that how many times that observation has occurred. So here we can see that the number of times that the student have played score is 1. So how many students have played sports last month? 1 time, 4 students. The number of students who have played twice sports in last month are 9, and so on. So from this frequency distribution, we can interpret the result, or we can draw the conclusion that most of the students have played sports twice, as the number of students who have played twice is are 9, and 9 is the maximum frequency in the frequency distribution table. Here is our today's topic, construction of frequency table. On the basis of types of data, there are 2 types of frequency distribution. These are discrete frequency distribution and continuous frequency distribution. Let's understand these types of frequency table here. Discrete and continuous classes. Discrete. In this case, the data in a class can take one discrete value. As we can see in the example, we have 0, 1, 2, 3, 4 and so on till 10. Here we can see that the values are with jump, like 0, then after 0 directly we have 1, then after 1 we have 2, 3. Means we have discrete values here. The values are with jump. After 0 there are not range of values like 0, 0.1, 0, 0.1 like this. However, if we talk about continuous frequency distribution, so in this case, the data in a class can take any value in a range. For example, we have here the class interval or classes here, that 0 till 1. Means any value greater than 0 and less than 1 will come in this class. So here in this class, there may be a range of values like 0, 0.1, 0.2, 0.01, and many more values between 0 and 1 will come or will fall in this class. Similarly, any number greater than 2 and less than 3 will be in the succeeding class, in the second class. So as it is discussed here, that on the basis of types of data, there are two types of frequency distribution. So it means that discrete and continuous frequency distribution depend on the types of data. For instance, if the data is about the numbers of people, like we can say number of students, number of members in various family, numbers of educated people in a city, so for that we can use discrete frequency distribution, as we cannot have the data in this here in this example, like 1.5, as a student cannot be 1.5, or number of people cannot be 2.5 or 10.5. So discrete frequency distribution can be used for such type of data. Whereas in continuous frequency distribution, the type of data will be such that, like, the data can be about the weights of the students, about the height of the students, about the marks of the students. As height, weight, and marks can be in decimal as well. So here we can have the range of values in continuous frequency distribution. Here is some more explanation about continuous frequency distribution. Here we have marks of students of class 10. So the students whose marks are between 150 and 153 will fall in this class, or will be recorded in this class. So any student with marks 150.5 or 155.5 will be recorded in the first class, whereas the marks between 154 and 157, like 156 156.5 it can be. So the students with such marks can be recorded in the second class. So this is continuous frequency distribution, where a range of values will be in a particular class. Let's have some more explanation of the topic here.
Grouping is used when the data we have is very large, and the groups are called class intervals. In one of our examples, we had seen groups like these: 1 to 5, 6 to 10, 11 to 15, and so on. There are a few things we need to know about class intervals. The class intervals should be non-overlapping. It means that the same number cannot be present in two or more groups. One number should belong to just one group. All the groups should exhaust all the data we have with us. These three groups are enough to cover all marks from 1 to 15. But if we had someone who scored a 16, these three groups would not be enough. Next, the class size or the class width should be the same. Class width is the difference between the two lower limits or two upper limits of continuous class intervals. So 6 minus 1 should equal 11 minus 6, and 10 minus 5 and 15 minus 10 should also be equal. Remember, they shouldn't be overlapping. The intervals should cover all values in the data, and the class width has to be the same throughout. There is just one more condition we need to keep in mind. In the first interval, 1 and 5 are class limits, and the average of 1 and 5 is called the class mark. The fourth condition says that the class limits and the class marks of each interval should be integers or simple fractions. A simple fraction is a fraction in which the numerator and the denominator are both integers. These are the basic rules we need to keep in mind while making groups or class intervals.
And let's have some more explanation of the topic here. As we discussed about continuous frequency distribution, so here are some concepts involved in a continuous frequency table. The first one here is class limits. The minimum and maximum values defined for a class or group are called class limits. The minimum value is called the lower class limit, and the maximum value is called the upper class limit of that class. Let's better understand this with the help of an example here. In this example, the lower class limits are 44, 49, 54, and so on, or etc., while the upper class limits are 48, 53, 58, and so on. So class limit basically give a limit to a particular class. For instance, in the first class, the limits are 48, 44 and 48. 44 is the lower class limit and 48 is the upper class limit. So this limit states that the weight greater than 44 or 44 and less than 48 will be recorded in this class. So this is basically the class limits. Next concept we have here, class boundaries. The real class limits of a class are called class boundaries. Let's better understand this with the help of an example here. We can see here class limits where we have the limits 44, 48, then 49, 53. And here we have class boundaries 43.5, 48.5, then again 48.5. So what we can observe here, that in class limit we have a jump, means after 48 we have 49. So the question arises here that if any means weight, any student or any person will be with a weight 48.2 or 48.5, 48.9, so that observation should be recorded in which class? So in order to overcome that problem, the concept of class boundaries is introduced. So class boundaries are the numbers that separate classes without forming gaps between them. As here we can see there is no gap, 48.5 again 48.5, so this is continuous here. So this is the significance of class boundaries. The distance from the upper limit of the first class to the lower limit of the second class is 1. We can see the difference between 19 and 18 is 1, and half the distance is 0.5. So for making the class limit continuous, or for finding the class boundaries, what is the step for it? We have to deduct or subtract 0.5 from the lower class limit, and we are going to add that 0.5 on the upper class limit. So here we can see that if we subtract 0.5 from 44, so we'll get 43.5, and if we add 0.5 here, so we'll get 48.5. Similarly, if we subtract 0.5 from 49, so we'll get 48.5, and the same so on. So here we have the classes now without gaps. So we can record any value with decimal also here. Any value means with decimal like 48.5 can be recorded 48.4, 48.3. But here is again one confusion, that if means 48.5 is here as well and here as well, means the in upper class limit and in lower class limit of the succeeding class. So where the 48.5 should be recorded? So the recommendation for that is that it should be recorded in the first class, not in the second class. So if the number or the weight is 48.5, it can be recorded in this class, or if the weight is greater than 48.5, so it will be recorded in the succeeding class. Here is another example of class boundaries. Here we can see that 70, then 74, 75, 79. Here we can see that the values are we jump at after 74 we have 75. So what about any value greater than 74? Where it should be recorded in which class? So for that purpose class boundaries are used. As we deduct 0.5 from 70, we'll get 69.5, and if we add 0.5 on 74, so we'll get 74.5, and so on. So this will make it continuous. Here we have another concept known as midpoint or class mark. For a given class, the average of that class obtained by dividing the sum of upper and lower class limits by 2 is called the midpoint of that class. Here we have the lower class limit and here we have the upper class limit. If you want to find the midpoint, or known as class mark, so what we have to do, we have to add this lower class limit with upper class limit, and we have to divide it by 2. Why by 2? Because we have to find the half, the midpoint of that, so therefore it must be divided by 2. As half of 3 is 1.5, similarly 4 plus 7 will be 11, and half of 11 is 5.5. So in this way we can find the midpoints of the classes. Here is some more explanation of determining the midpoint as lower class limit plus upper class limit, and it should be divided by 2. Okay, here we have another concept known as cumulative frequency. The total of frequency up to an upper class limit or boundary is called the cumulative frequency. Let's better understand this with the help of an example here. Here are the classes and here are the frequencies, and here we have the cumulative frequency. So let's understand it like this, that let this example be related to the marks of the students. So the number of students whose marks are between 0 till 10 are 3. The number of students whose marks are between 10 to 20 are 8, and so on. So here we can see that frequencies are given, and if we are interested to find the cumulative frequency, so in cumulative frequency we are going to add the frequencies in each successive class. So here the frequency will be 3. In the next class, 3 plus 8 will be 11. In the next class, 3 plus 8 plus 9 will be 20. And then 3 plus 8 plus 9 plus 15 will be 35, and so on. So the total means frequency will be at the end will be equal to cumulative frequency. Now let's come to know that what is the use of this cumulative frequency. For instance, this can be used if you are interested to know the number of the students whose marks are means less than or equal to 20. So how many? 3 plus 8, 11. If you are interested to know that how many students have scored or whose marks are between 0 till 30, so you will add all these 3 and you will give the answer 20. If you are interested to know that how many students, the number of the students whose marks are between 0 till 40, so you will add 15 as well and you will get 35, and so on. So this is basically the use of cumulative frequency. Here we have exercise 6.1, question number 1. The following data shows the number of members in various families. Construct frequency distribution. Also find cumulative frequency. As we know that the data is about the members or about the people, so therefore we can use discrete frequency distribution here. So for having a discrete frequency distribution, the first step is to find the minimum observation and the maximum observation. You have to go through the data and find the minimum observation. We can see here that 2 is the minimum observation, whereas 12 is the maximum observation. Because in order to have a proper organization of the data, we take a start from the minimum observation and we proceed towards the maximum observation. So let's have the discrete frequency distribution here. Here we are going to write the number of members in various families. So the minimum observation is 2 and we have to proceed towards the maximum observation, which is 12. Then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This all values or observations exist in the raw data here. So for recording data, we are going to use tally marks. If we will write the observation itself, like 2 how many times? 1 time, so we can write 2 here, but it will be much time taking, so it's better to use tally marks for ease. We can see here 3, so how many times? 3, 3, 3 and 3 times, so we can write here. 4 how many times exist in the data? 4, 4, 4, 3, 4, 5, 6, 6, and 5 times, and so on. If we see that 12 how many times exists? 12 exists just 1, so we can write 1 here, and here we can write the frequency then. If we will write the number of observations, like time and again we write 4, 4, 4, and 6 times we write 4, it is also correct, but it will be much time taking, so it's better to use tally marks. Okay, here are the frequency, and we can see here are 39. This total frequency is 39, and if you count the number of observations, so it will be 39. So you can check the total from here. Okay, so we can interpret the result here that here we have one family in which the number of members are 2, and which frequency is higher. So we have 6, 6, and 6. So we have we have 6 families such that in which the number of members are 4. Again, we have 6 families such that in which the number of members are 7, and we have 6 families such that the number of members are 9. It means that average can be 4, 7, and 9 then. Okay, Then we have cumulative frequency. As it is asked that we have to calculate the cumulative frequency as well, and we have discussed already the cumulative frequency, that in cumulative frequency in each successive class the frequency will be added. As here 1, then 1 plus 3 will be 4, then 4 plus 6 10, then 10 plus 4 14, 14 plus 3 17, and so on till the end we will get 38 plus 1, it will be 39, not 9. So here is the frequency distribution or discrete frequency distribution for question number 1. It is done. Here is your assignment for today. You are going to do page number 117, exercise 6.1, and question number 1 only. This is all for today. Have a nice day. Stay blessed.